estimate the total mass of atmosphere. Okay, how does one do that? So everybody knows mass of Earth. Okay, I mean, generally those are written and many people remember that. But suppose I want to estimate the total mass of atmosphere. What will I do? So which principle will I use? Now, one of the principle which can be used is, we know atmospheric pressure. And we can estimate the surface area of the Earth, because you know radius of the Earth 6,400 kilometers is what many times people remember. And then you can do the calculation that what is 4 pi r square, and you can get that number. So that will give you the gravitational force by atmosphere on the Earth. So you have atmospheric pressure, which is about 1 bar, approximately 10⁵ pascals. And then you know the surface area 4 pi r square, and r you know. So that surface area multiplied by pressure gives you the force, and this force is nothing but gravitational force of atmosphere. It is weight of the atmosphere. And one additional assumption you will have to do, since the atmospheric height is very small as compared to the radius of the Earth. Atmospheric height is how much? It is about we say about 10 kilometers. Surely it doesn't go beyond 100 kilometers. And as you go up, of course, it starts becoming less dense. So mainly dense atmosphere, if you consider, it is about, say, 10 kilometers or so. And then you can assume that when you go distance at 10 kilometers, okay, as compared to 6,400 kilometers, which is radius of the Earth, the G is not going to change much. The gravitational acceleration is not going to change much. And then you can say that, okay, I will use value of G as, say, 9.8 or 9.8 meter per square second, or say, even I can approximate, because I'm estimating to 10 Newton per kilogram or 10 meter per square second. Now, this will give estimation of mass of the atmosphere. So what you've done is you've calculated the atmospheric pressure, which is 10⁵. Then you are multiplying with 4 pi, which is approximately 10, and into r square, so 6.4 into 10⁶ meters square of that. And then you can see that that value 6.4 square can be approximately 40, okay, and into 10⁶ square, so that will be 10⁻²². And then you have 4 pi, which you have approximated as say 10. And so effectively you get something like 10⁻² into 10 into 40. So that is about 4 into 10⁻⁴. And then you multiply with 10⁵. So that gives you something like 10⁻⁹ newtons, and you divide by 10. So that you get approximately 10⁻18 kilogram as mass of the atmosphere. So 10⁻18 kilogram, you see, is very small fraction of 10⁻24 kilogram. So, but this is how one can estimate